Welcome to episode 5 of Exploring SD-WAN 20.15.1. My name's Terry Vinson, and in this video, we're going to explore adding OSPF as a service-side routing protocol in VPN 100 and VPN 200 to include bringing up OSPF neighbors, and we're going to start right now. In order to bring up OSPF neighbors, we're going to need to add some resources to our environment. Specifically looking at step 1, we're going to add 2 CSR 1000 Vs to the topology, and we're going to connect them to CEdge 1 and CEdge 11. We're going to turn those on, and while they're coming up, we're going to go ahead and enter the SD-WAN vManage so that we can make manipulations and changes. So let's go ahead and see if we can't get these 2 CEdges added. I'm going to drag my topology down just a little bit just to give me some more room to work. And I'm going to go ahead and go to the Add Object, Select Node. I'm going to go ahead and pull up CEdge, CSR 1000 Vs. I'm going to go ahead and take the XE16 version. I'm going to say I want 2 of these, and we're going to call them R some value. And like I said, we will go ahead and create these. I'm going to grab the first one, and I'm going to attach it to CEdge 1, and I'm going to grab the second, and I'm going to attach it to CEdge 11. I'm going to go ahead and change the designations for these. So instead of R8, I'm going to go ahead and edit this, and I'll change its name to, let's go ahead and say 201. And down here, we'll say 202. Next, we want to connect these devices together. So R201, interface Gigabit Ethernet 1. I'm going to go ahead and connect it to CEdge 1. I'm going to go ahead and pick CEdge or Gigabit Ethernet 4. And we'll use the same interface on CEdge 11. Because we want to use one common template. So we'll make that uniform, Gigabit Ethernet 1 to Gigabit Ethernet 4. And we're going to turn those on. So right-click, start, and right-click, start. All right, now that that is going, I just want to make certain that both of the devices have come on. Let's take a look at the next step. So create a custom OSPF feature template. Well, this is going to be very similar to the way that we did things when we were creating the BGP feature template. So let's navigate to the vManage and log in. All right, we are in the vManage. We're going to go to Configuration, navigate down to Classic, select Templates, navigate to Feature Templates. We're going to create a new one. It will be for a C8000V. Scroll down to Other Templates. Select OSPF. And provide all of the necessary information. So in this instance, I'm going to go ahead and say that my template name is going to end up being Custom OSPF. I'm going to go ahead and do this for VPN by VPN. So we'll go ahead and say VPN 100. Actually, let's go ahead and put template on the end of this. Put that into the description. Okay. So router ID, not going to worry about it. Pretty much the only thing that I'm going to need to really do is just go to area. We're going to define an area. We weren't told what area to use, so I'm going to use area 0 everywhere, and I'm going to need to specify an interface, which is going to be running an OSPF, keeping in mind that in SD-WAN, we run using interface-based configuration, very similar to the way we do things in the Nexus operating system. But right now, I'm just going to go ahead and ask for a device-specific variable, and we will call that device-specific variable VPN 100 OSPF interface. So that'll ask me for the name of that OSPF interface designation. So there we go. So do I need to manipulate the hello interval? No. Do I want to manipulate cost? No. So we should be relatively good to go here. So we could set up the area type, but we have no instruction for that. So let's go ahead and select add. Any of the advanced configurations, we've been called upon to make no manipulations. So we're going to go ahead and select save. Now what I'm going to do is I'm going to sort on OSPF. And I'm going to try to find the, SPF. I was going to say, that doesn't make sense. OSPF. There we go. I'm going to copy this one, and I'm going to make a duplicate for VPN 200. I want to use specific variable designations to mitigate the possibility of confusion. So I need to edit this one. So we'll go in and we'll say edit. And again, I'm just copying it because it gives me a way of being able to do things quicker. I haven't tested it yet, but the configuration will be for area. We want to edit the area 0, and I need to change that variable designation. So update the area. Edit. It's going to be the same area. We'll select interface. And instead of saying VPN 100, I'm going to say VPN 200. Save changes. Save changes. Update. So now we should have 2 OSPF feature templates for defining the OSPF process and area. The next thing I'm going to want to do is I want to create an interface template. So I'm going to create one for each of these. So again, what we'll do now is we'll go ahead and say add a template, because this is going to be an interface template. It will be C8000V. We'll select it. We'll do the one for 100 first. So we're going to scroll down to VPN interface Ethernet. We're going to go ahead and call this custom. VPN 100 interface template. We'll just copy paste like usual. So we want to make certain that globally our interface is going to be no shut. We will need to specify an interface name. In this instance, we're going to be using a sub-interface because it's going to be applied on the gigabit 4 interface of the device. So in this instance, I'm going to go ahead and say VPN 100 interface name. In fact, I'm going to go ahead and just say sub interface name, just as a reference. All right, and then I'm going to need to do a VPN 100 sub-interface IP mask. That'll be what we put here. So we'll say VPN 100-sub-interface-IP-mask. Again, long names. No tunnel, no NAT, no VRP, no QoS. We should be good to go. So I'll go ahead and select save. VPN, I must have accidentally hit VPN 100 interface. Oh, it's using the exact same name I use for the loopback interface. So we're going to need to give this a different name. So we're going to go ahead and say G4.100 interface G4.100. In fact, since that's the case, what I'm going to do is instead of asking for a variable, I'm just going to globally change this to gigabit 4.100. Actually, I have to do the whole thing spelled out. So gigabit. Again, it's case sensitive as heck. So that's the IP address. Sorry. Oh boy, I'm gonna go back and change. Put that back where it was. All right, and what I'm getting at here is that this template is going to end up being for a specific sub interface. So there's no reason to ask to provide it. So the field that I should have modified was this one. So instead of using a variable, what I'm going to do is I'm just going to globally make this gigabit Ethernet 4.100, and I'm going to have to ask for the IP address for 4.100. So down here, let's go ahead and see if we can't make the value make sense. So we'll say VPN 100 gigabit 4.100 IP ask. There we go. So that should make sense. All right. So let's go ahead and say I want to look at anything for VPN 100. So I should actually have a gigabit Ethernet 4 interface for VPN 100. I'm going to end up having the custom template already in place for the 2. So this was where my duplicate was. So these are the 2 that I'm looking at right now. So from VPN 100, I created the OSPF instance, and I created an interface instance. So what I'm going to do now is I'm actually going to come over here and copy this one, and I'm going to make it for 200. That's the OSPF template. Actually, I forgot I created one of those. Where is it? Oh, my sort is killing. I just need to make the second interface template. So we'll go VPN 100. Let's take a look at VPN 200. So there's the 200. I now need the interface template, but what I'm going to do is I'm actually going to clone 100. Let's just see if we can get them both in here. So 100 and 200. So that's an and, so that's not going to work. So VPN 100, I'm going to grab that interface template. I'm going to copy it. We're going to change it to 200. Copy it. Now, unfortunately, it's going to go away. So we're going to say gigabit for 200. There it is. We're going to edit it. Change the variables. Now, we also need to change the global interface designation. So first things first, this is going to be 200. Second, we're going to go down here and change the variable, device specific. We're going to change that to VPN 200, gigabit Ethernet 200. So that should be sufficient to the task. Let's go ahead and say update. All right, so now I have all of the parts that I need. So the plan now is to look at the task. The task says that we add this new feature template for both VPNs 100 and 200. So fundamentally, all we're going to do is access the device template. We're going to navigate down to the service VPNs, and we're going to add OSPF to each of the service VPNs 100 and 200 respectively. So let's go ahead and do that. So I'm going to scroll all the way up and select device templates. We'll find the custom device template that we created. We're going to edit it. We're going to go to Service VPN, and I'm going to need to edit the 2. So in VPN 100, the plan is I want to edit. I'm going to go ahead and add another interface for the VPN, and I'm going to add OSPF as a routing protocol. So we'll choose the routing protocol for OSPF. This is for VPN 100, so there's the one I'm going to choose. We'll choose VPN interface, the one for 100. We'll go ahead and save. Next, we'll edit VPN 200 and do the same thing. We need to add another VPN interface Ethernet, and we need to add OSPF. This is for 200, so we'll pick 200. And we will go ahead and choose VPN 200. Oh, VPN 100, gigabit Ethernet 200. Save. And update. Now that the vManage realizes that I've made modifications to a device template that has resources attached to it, I need to now provide the variable information. So let's see, we are going to need to have some IP addresses. So I'm going to go ahead and say, this is going to be, we'll just right click on this and we will edit it. This is going to end up being, we'll do 10, site 1 will be the second octet, and VPN 100, actually we'll do X00, and then what we'll do is we'll say 0. So there'll be an IP address for 100.0/30 and one for 200. So that'll work. So down here, what we're going to end up doing is the same thing, except this is going to be site 2. So that will end up being 10.2 for site 2. And we will go ahead and say X00/30. So for whatever VPN we create, 100, 200, etc. So there we go. All right. So those are going to end up being the addresses that we're going to use to apply. And again, the way we'll do it is we will do the router will be the .1 out of each of those ranges. And then the devices will be .2. All right. So on the devices, the address that I need to apply here is going to end up being for site 1 will be 10.1. In this case, it's a 200 IP. So in this instance, it'll be 200 and a third octet. And in this case, this will be .2/30. This guy will be 10.1.100. Sorry, 10. Site 2, 200, 2/30. And I'm also going to have to apply the second address for VPN 200. Hold on, I've got, oh yeah, the interface. So that's the mask. So the next thing it's going to ask me to, I'm going to go ahead and just use the 3 dots for the variables. This makes more sense to me. It's just easier for me to read. So the IP mask for 200 is 183.200.1.1. The interface for 200 is going to be 10.1 for site 1. See edge 1, 200, 2. That's correct. The interface that I want to run in 200 OSPF is going to end up being gigabit Ethernet 4.200. So that part is good. So the next thing that I'm going to need to do is I am going to need to configure the interface IP for 100. I've missed something. So the way this should go down is I should be able to apply the IP address and mask for both interfaces, gigabit 4.200, gigabit 4.100. I should be able to advertise OSPF in 200 and 100. So there that is. All right, so yeah, that's the issue here. So 10.1.100.2/30. And I also want to advertise gigabit Ethernet 4.100. Giga Ethernet. So let's give this a try. Now that should give me a green check mark. So now what I'm going to do is I'm going to pretty much do the same configuration. So we've got Site 2, VPN 200, IP mask done. The interface that I want to advertise in VPN 200 is going to be Gigabit Ethernet 4.200 on that device, C-Edge 11. The IP address for 100 is going to be 10.2.100.230. So anything that changes is the second octet. And the interface that will be advertised will be Gigabit Ethernet 4.100. So VPN 100. 100 becomes the sub-interface designation. So let's go ahead and hit next. And I'm going to click on one of these just to make sure that there's no errors. Config diff side by side. Take a look at the mods. We're looking for green. So Gigabit Ethernet 4.100 with an IP address of 10.1.102/30. That's all good. Gigabit Ethernet .200 with a 200.2. OSPF is running at the interface level. Default hellos for a broadcast environment. So let's go ahead and select configure devices and see if we can push the configs. Action. We'll monitor the log. Okay, let's check it from the CLI. So we'll go to our secure CRT session. We're going to navigate to C-Edge 1. I'm going to go ahead and log in. Show IP interface brief, assigned addresses. There is 100, there is 200. If I say show VRF, we look at the output. I have VRF 100 with the loopback and the sub. I have VRF 200 with the loopback and the sub. If I say show IP OSPF interface brief, and we look at what's going on, we can see that we are running OSPF, but we have not formed any neighbors, and that's because none of the configuration has been made to our routers. So let's go ahead and get into those. So we'll have to wait for the wizard to do its thing, obviously. So, all right, 201 and 202. All right, so I didn't give these guys more RAM, which is normally what I've been doing. So these are going to be pretty slow. I keep forgetting to do that. So no. All right. Here's what I'm going to do. I'm going to go ahead and stop right here. I'm going to shut these off. I'm going to change their memory. So I'll walk through that. So right click, stop, right click, stop, right click, edit. We're going to go ahead and increase the CPU to 4. And I'm going to go ahead and say, let's say we'll say 16,384, which is a lot. And down here, I'll do the same thing. I'll say edit. We'll say 4 and 16,384. Save. We'll turn those back on. And when they're up and operational, I'll pick back up. So I'm going to go ahead and pause the video. Once these guys restart, I'm going to go ahead and select them. And like I said, when the devices come back and are operational, I'll go ahead and restart the video. So I'm going to hit pause right now. All right, the devices have reloaded. And just for everyone's edification, 8 gigs would be more than enough to do this. I'm just using a really large server, so it doesn't bother me to throw 16 384 at a C-Edge in the lab right now, actually at a CSR 1000V. So let's go ahead and do the configuration on R2. So yes, actually, no, I want to bypass that. I'll go ahead and do the same thing on no. Yes. And once the box comes up, we're going to do the initial configuration on it to get it set up to run OSPF. So I'm going to go ahead and say config T. We're going to give it a host name of R201. Next thing I'm going to do is I'm going to go ahead and configure interface gigabit 1. I'm going to say no shut. I'm going to go to interface gigabit. Sorry. We're going to go to interface gigabit 1.100. Actually, let's do the VRS first. So VRF definition will be 100 IP or address family IPv4. We'll do 200 IP address family IPv4. All right, so that part is why I open PowerShell. So we have the address family. So the next thing we're going to need to do is configure the physical interface. So it's going to be interface gigabit Ethernet 1. I already did the no shut. I'll just repeat the syntax. We're going to do 1.100. We're going to put it inside of VRF forwarding for 100 IP address. In this case, we said it was going to be 10.1 since it's site 1, VRF or VPN 100. And this guy's going to be 1.255.255.255.252. Oh, I forgot the encapsulation. .1Q100. I'm spoiled. There we go. All right, so no shut. Then what we'll do is we're going to go to gigabit 200. Internet 4. Sorry, 1. 200. We are forwarding for 200. Encapsulation .1Q200. And IP address 10.1.200.1.255.255.252. And we'll do no shut. All right, so I'm just going to end this and do a show IP interface brief, exclude assigned addresses. And I just want to test reachability, so I'm going to do ping VRF 100, 10.1.102, and see if we've got reachability down to our device. And we're going to ping VRF 200 to the same address, except for the third octet. We have reachability. So let's go ahead and configure a loopback for each of these configs. So I'm going to say config T. We said interface loopback 100, VRF forwarding for, we will go ahead and say 100. We're going to need to give it an IP address. We said that 183.100, so that's going to end up being 183 means a loopback in my lab. Second octet corresponds to the VPN. This guy's going to be 201, 201, 255, 255, 255, 255. No shut. Not that you need no shut loopbacks, but I've taken enough CCIE exams to be paranoid. So we're going to go ahead and do loopback 200. Same thing. VRF forwarding for 200. We're going to say IP address 183.200, 201, 201, 255, 255, 255, 255. All right, so let's do the routing process now. So I'm going to follow suit with what happens on our C-edges. So if we were to look at the OSPF configuration that was applied by the vManage, I'm going to say show run pipe section router OSPF. And again, I'm on C-edge 1. and we're going to look at the configuration. What I want you to note here is that the vManage configured a router OSPF process of 100 in VRF 100. Now, in iOS XE operating in controller mode, these numbers have to match. Now, they don't have to match between devices. OSPF process doesn't matter on either end of a link. But for consistency's sake, I'm going to go ahead and follow that same solution. So on 201, I'm going to say router OSPF process 100 VRF 100. And then what I'm going to do is I'll say router ID 0000201. And I'm going to say network. I'll start with the loopback. So anything in 183, put it in area 0. And then the next thing I'm going to do is I'm going to do network 10 1 0 0 0 0 255 255 area 0. And let's see what happens with regard to neighbor adjacency. We can see here that I immediately got one. So the next thing I'm going to do is I'm going to go ahead and create another router process. Router OSPF 200, VRF 200, router ID 0000201, and I'll say network 183.0.0.0. In fact, I could just copy and paste those. So 0.255.255.255 area 0. And we'll do network 10.1.0.0.0.255.255 area 0. Don't match anything with 10.1. All right, so end, we'll do a write on that. And now what we should see here is I should say show IP OSPF neighbors, and we should now actually have those adjacencies up and operational. And if I say show IP route or VRF, we'll go ahead and say 100. Something doesn't look right. I'm not learning anything from CEdge 11 via the overlay, but that's fine because we haven't done any configurations. So let's go ahead and get it configured, and then what we'll do is we'll check it. So from the perspective of the resource, let's go ahead and get into 202, en config t, host name. It's going to end up being R202, and we want to get the VRFs, so we'll do VRF. Actually, you know what? I'm going to copy and paste just to make my life a little bit easier. So here I'm going to say show run pipe section VRF definition. Now I'm going to get more than I bargained for. Actually, no, I won't. This is just a standard router. So we'll go ahead and just paste that in here. All right, so now we've got VPN VRF 100 and 200. So the next thing we want to do is interface gigabit 1. I'm going to go ahead and say no shut. Interface gigabit 1 100. We're going to do VRF forwarding for 100. And we'll go ahead and say IP address. We said 10. In this case, it's site 2. So the second octet will be 2. It will be 100. In this case, we said it would be .1. 255.255.255.252 encapsulation .Q100. Then put that IP address in there. No shut. Interface gigabit 1 200 VRF forwarding 4 200 encapsulation .1Q 200 IP address 10 to 200 1 255 255 255 252 no shut exit. Now what we need is we need the routing process to function. So we'll say router well actually let's go ahead and do the loopback interfaces first. Loopback 100 VRF forwarding for 100 IP address will be 183.100.202 202 255 255 255 255 no shut. Interface loopback 200 VRF forwarding for 200 IP address 183.200.202 202 255 255 255 255. no shut. Now we'll do the routing process. So we'll say router OSPF. In this case, I'm going to say 100 VRF 100. I'll do router ID 0000202. Network, we'll do the loopback first. So it'll be, in this case, it will be 2000255 area 0 and network 10.2.0.0.0.255.255 area 0. Let's go ahead and do the routing process for VRF 200. Router ID 0.0.0.202. Network, we'll start with the loopback. 0. And then we'll do the links between 10.2.255.255 area 0. And right, let's see if we get our second neighbor up. And what we're going to find here is show IP route for VRF 100 and show for VRF 200. Now, what we've got going on here is kind of interesting. If we take a look at the routing tables, what we see is we're not learning any routes. Now, remember, the last time we talked about what happens in OMP by default, we mentioned specifically that OMP dynamically advertises static and connected routes. It's also assumed that it's going to dynamically advertise internal routes for routing protocols like OSPF. EIGRP is a little bit different as far as how it functions because it was bolted on after the fact. But right now we're running OSPF, and OSPF is a standards-based protocol, and Viptela has adapted to supporting it for a number of years. So what I want to do right now is I want to validate whether or not these prefixes are being advertised to the vSmart. So let's jump in and take a look at that. So let's look at our configs here. So just looking at configuration, we configured the CSRs, we brought up the adjacencies. What we want to do now is we want to confirm that these prefixes are being learned and advertised by the vSmart. So the first question is learned. So let's take a look. We're going to go to the validator. We're not the validator, we're going to go to the controller, log in, show OMP routes for VPN 100, and I'm going to go ahead and put it in a tabular format just to streamline it. And we look at the networks that are being learned. So there is 183.100.1.1. There is 11.11. We see 201.201. Let's take a look at the output for VPN 200, and let's see if we are learning about 202. So there's the routes for 202. There's the routes for 201 inside of VPN 200. So this clearly demonstrates the fact that I'm learning those routes from the SDWAN and SDWAN at this juncture in our lab. Now, the next question is are we advertising those routes out? Remember, we can type show OMP routes, and I can look at advertised, and if I specify the VPN first, VPN 100 advertised, we can see what we're advertising out. Well, notice that routes learned from SDWAN are being advertised to SDWAN in Site 100. Notice that routes that are being learned from SDWAN in Site 100 are being advertised to SDWAN in Site 1. So this tells us that we're learning and we're advertising. And if we were to go to, say, for instance, SDWAN and type show IP route for VRF 100, I'm used to using 10. Notice when we look at what's going on here, when we look at routes we're learning, there is the route from SDWAN that is being originated and advertised out towards us, and there is the route to 201 that is being advertised locally or learned locally inside of our configuration. So if I were to say show SD-WAN OMP routes for VPN 100. Let's look and see what we're learning via OMP. Now, from OMP's perspective, we can see here I am learning about Site 2. I am not learning let me expand this. Sorry, the fact that it wraps sometimes makes it hard for me to kind of interpret what's going on here. So when we look at what we're learning with regard to OMP routes in our configuration, that's being originated locally. This is being originated locally. This is being originated locally. This is being learned from the vSmart, and this is being learned from the vSmart. Now, interestingly enough, I'm not seeing 183.100.202 show up in this list. So need to do a little bit of troubleshooting. If I log into the controller, can I see show OMP route for 183.100.202.202/32? Does it show up in my table? No. Let's take a look at 200. All right, that's in my table. If I do a tab, we can look at it. So it doesn't look like I'm originating that route in VPN 100. So let's double check and make sure I didn't make a mistake. So I'm seeing everything except for show IP interface brief assigned addresses. So I'm not learning that route right there. Show run interface loopback 100. It's there. Show run pipe section router OSPF for 100. Oh, there's what I did wrong. I used .2 instead of .200 or .100. So, yep. You guys were probably screaming at me the whole time. We'll just paste this in. I'm going to say no. And then I'll say network 183.200.0.255.255 area 0. And right. All right. So now that should fix my problem. Let's go over to the controller and see if I can find, there's the route for 202 in VPN 200. Let's go ahead and check 100. Man, I'm all over the map. Yep, I did 200 in 100. So still wrong. All right, so no version of that. Network 183.100.0.0.255.255 area 0. And right. Okay. One more time, Terry. All right, there is 100. And here is 200. All right, so they're both in there. So now let's see if this makes a little bit more sense from the perspective of C-Edge1. I want to see the routes for 183.100.202. There they are. But here's the scenario. We are dynamically advertising internally learned prefixes without making any modifications or changes to our OMP featured template. We're dynamically advertising those routes out towards the vManage. Now, we had to, and we took a look at a couple of things when it came to setting up the routing process. But the problem that we have here is that if I were to navigate up to, say, for instance, R201 and say EN and say show IP OSPF, show IP route OSPF. Actually, we just do show IP route. Notice I'm not learning any routes at all. And if I say for VRF100, the only routes that I have are going to end up being in the ones that I'm generating locally, and I say for 200. Now, the fact that I don't see anything in the global routing table, that's normal. That's what we configured. By creating VRF100, we created a routing information base for it. And by creating VRF200, we created a routing information base for it. Now, the scenario that we have here is that we have this process whereby routes that are learned that are going to end up being connected, like our loopback addresses, or static, if I configured a static default route or some other static route, and internally learned prefixes for OSPF will all be advertised directly to the vSmart directly with no modification on our part. However, those routes that are going to be learned in the transport side, so we're going to be learning and exchanging routes due to our peering relationships with the vSmart. But what's not happening dynamically is OMP routes are not being redistributed into OSPF. And it's kind of a surprise for many people because what we're actually seeing here is that the OSPF learned internal prefixes are actually being dynamically redistributed into OMP so that they can be communicated to the vSmart, but the reverse doesn't take place. So what we're going to end up having to do is we're going to have to modify our OSPF feature template to include a setting that's going to redistribute OMP routes into OSPF. To do that, we're going to navigate to our vManage. We're going to go to Configuration, Templates. We're going to go to Feature Templates. And what I want to do is I'm going to need to take a look at the OSPF templates. Now, here's the dilemma. We have two choices. I could go and detach the template, make my changes, and then reattach the template. I could go to the device template and put the device template in draft mode, but subsequently, any changes would still force me to compile the CLI modifications, so it still eats into our time. So at this point, all I'm going to do is modify VPN 100 by editing it. Oh, this is, yeah, I thought it was the VPN, the interface template. So I'm going to go to redistribute, and I'm going to select a new protocol to redistribute, and that protocol from the drop-down menu is going to end up being OMP. Add. Now, this is the drawback. When I hit update, the vManage is going to realize, hey, Terry, you need to make a change to push the configuration to these two devices, which I need to approve and press configure and say, go ahead and confirm to do it on both of those devices so that the configuration will be applied, but it's only going to be applied to VPN 100. So once this has been done, I need to go back into the vManage and I'm going to need to modify VPN 200. Now, just jumping over and starting to make the change is not something that I advise people to do. I would recommend you wait until this change is made, then go back and modify VPN 200, because sometimes you can run into a stacking problem where the vManage is waiting to do something and it's waiting until it finishes doing something else. And if something happens or if there's a problem, it can basically make some confusing scenarios, or at the very least, you'll end up waiting a lot longer to do something than you would ordinarily end up waiting. So we've successfully applied. Let's go ahead and go back to templates, to feature templates, to OSPF. We're going to select VPN 200 and make the same change. Edit. Redistribute. New redistribute. OMP from the drop-down menu. add, update. Push the config. Confirm. Monitor. All right, it's successfully completed. Let's go ahead and take a look at the last step here. We want to test reachability via the CLI and the vManage UI. All right, so first, let's go ahead and see if those routes are being learned from the perspective of our 201, which is going to end up being in the Site 100 location. I'm going to go ahead and say show IP route for VRF 100. And notice I'm now learning E2 prefixes because we redistributed those OMP learned routes by the transport side. We're redistributing them into the service side OSPF routing process. So if I say ping VRF 100, 183, 100, 202, 202, let's see if I have reachability. And I do. And if I do a trace route to VRF 100, 183, 100, 202, 202 numeric, what we're going to see here is it's traveling down to 100.2 as far as the link between R201 and C Edge 1. From there, it's traveling across the public internet connection where it's arriving on the destination. C Edge 11 is being sent to Site 2 100.1 as far as the reachability where it's being delivered to R202. So let's double check show IP route for VRF 200 and see if we have the same scenario where we're learning 202 and it is being learned as an OSPF E2 prefix. If I say show IP OSPF database, we can see here that I'm going to end up having type 5 LSAs that are being generated as a result of that redistribution process. We can see information that we're learning from and being generated by us locally and what's being advertised. So from, a 3,000-foot look here, this all seems to be well and good. Now, the other task was to validate this from the CLI. Or from the GUI. So I'm going to go to Monitor to Devices. We'll go down to C Edge 1. Let's go ahead and navigate down to Troubleshooting. From Troubleshooting, I'm going to go to Simulate a Flow. We're going to do our test in VPN 100. My source interface, I'm going to do it from my sub interface. And I'm going to go ahead and see if I can't hit 183. In this case, 100, 202, 202. And we can see here, it's going to give me the all available paths. And if all goes well, we should see two paths that we can follow, one through public internet, the other through MPLS. So there we go. Everything seems to be working exactly the way that we need it to work. Now, I've been receiving lots of requests from individuals that want to start exploring the concept of policies. Now, before we can do policies, there's a couple of things that have to be taken care of. The first policy that I'm going to tackle is going to be a hub and spoke topology, whereby we're going to create a policy where all data that's going to travel from what will be our spokes will need to traverse the hub. Now, the drawback to this is one, we don't have a second branch. So in the next episode, I'm going to add branch 2. We're going to onboard a C Edge there, which will be C Edge 21. And then what we're going to end up doing is we're also going to, in that video, create templates to apply to our vSmarts. Because as a general rule, you cannot create policies and enforce policies. You can create them all day long. You just cannot activate policies unless our vSmarts are vManaged. And as we've said, that requires the utilization of a template. So the next couple of episodes are planned out. My request for everyone that's watching this series is to begin giving me more input with regard to tasks you would like to see me cover. I have a list of tasks that I would like to go through in my own mind, but once I reach the end of that list, that's going to end up being the end of this series. If students or if viewers want to see more content, I'm relying on you guys to ask the questions in the comments below. And also, as with any YouTube video, it would really, really appreciate and greatly help the channel if we can get likes and subscriptions. And ultimately, at the end of the day, I would like this to go for as long as it needs to go. I'm really enjoying making these videos. There's less stress for them to be, absolutely perfect. But at the end of the day, that's all going to be dependent on what I have in my mind and the questions that you might ask. So I'm going to go ahead and stop here. You guys have a fantastic day, and I'll see everyone in the next video when the time comes.